Hi everyone. Last time we talked a little bit about systems of linear equations, and we learned how to solve them by graphing. So we're going to extend this a little bit and talk about the relevance of graphing systems of linear equations. But first, I really want to drive home a point that I didn't talk about in the last video, and that is that when you have a system of linear equations, each line consists of infinitely many points that are all solutions to its equation. So what I mean by that, what I mean by the fact that each point is a solution to the equation, is that I can pick any point, say on this line is y equals 2x plus 2, and any point that I pick, any ordered pair, so like 1, 4 here, or negative 1, 0, each of those numbers is going to satisfy my equation of y equals 2x plus 2. So let's just work that out first. So if we take 1, 4, 1 is my x value and 4 is my y value. So when I plug this point into my equation, it should satisfy it. So I'll plug 1 in for x and 4 in for y, so I'll get 4 equals 2 times 1 plus 2. This side is 2 times 1, which is 2, plus 2, which is 4. So I get 4 equals 4. Excellent. So that point works with my equation. That point satisfies my equation. This one should as well. It also falls on my line. So let's try it out. This is my x coordinate, negative 1, and 0 is my y coordinate. So I'll plug in 0 equals 2 times, and then I plug in negative 1 for x, plus 2, and I get that this side is negative 2, 2 times negative 1, plus 2, should equal 0. Well, negative 2 plus 2 is 0, so 0 equals 0. And that point also satisfies my equation, as it should. Now, when you have systems of linear equations, you have at least 2 lines. So if I had another line running through this one, say something like this, that line also consists of infinitely many points that satisfy its equation. But the only point that satisfies both this equation and the one for the line that I just drew happens to be at their point of intersection right there. All right, let's talk a little bit about how we might solve word problems with systems of linear equations. So there are 5 steps that I would use to solve word problems, and we will do some examples afterwards. And those steps are as follows. So first, we want to identify what we need to know. So before we can solve anything, we need to look at our problem and just, in plain English, decipher what we need to know. The second step is to define variables. So if you remember, when we look at word problems and we use linear equations, we always want to define our variables. Third step is to write a system of linear equations. Write a system of linear equations, so that means we're going to have to write at least 2, and in our case, we are going to write 2 linear equations. Then we need to graph each line given in our system of linear equations. And finally, using those lines that we graph, we need to determine the point of intersection. And that point of intersection is going to be my solution. All right, let's do some examples. Okay, so our first example, and before I read this, I want to point out that I'm going to be underlining some things that I find important, so you might want to do this as well. So our example is that Nyana went on a shopping spree for shoes and spent $131. Sounds important to me. Converses cost $15. Okay. And Nikes cost $28. If she bought a total of 7 pairs of shoes, then how many of each kind of shoe did she buy? All right, let's follow the steps that we identified before. So our first step is to identify what we need to know. What do we need to know? What are we asked here? Well, we're asked how many of each kind of shoe did she buy? Well, we need to know how many Converses and how many Nikes. So I'm just going to write down for myself Converses and Nikes, so that I know that at the end I need to figure out a number for both of these. All right, next step is to define our variables. So our variables are going to be what? Well, we're looking for a number of shoes, of number of pairs of Converses and a number of pair of Nikes. So I think those are pretty good variables. I'm going to define them as C for Converses. Just write this over here. And I'm going to call the Nikes N. And those will represent the number of each pair of shoes. All right, so our next step is to write a system of linear equations. So I'm going to write a system down here. And my system of linear equations is going to have two equations, as usual. And looking back at my problem, it makes sense that I'll need two because we talk about money, we talk about how much she spends and how much each pair is worth, but we also talk about the number of pairs that she buys. So money and the number of pairs don't really mix, which is why we need two equations. So let's first look at the cost. Well, we know that Converses cost $15 a pair, and we identified a variable for the number of pairs. So we can use that. We can say $15 times however many pairs of Converses she buys, plus the cost of Nikes times the number of pairs that she buys of those. So 28 times N should add up to the total amount of money that she spends. So should be equal to 131, and that's my first equation. My second equation is going to have to do with the total number of pairs of shoes that she buys. Well, we know that the number of pairs of Converses, or C, added together with the number of pairs of Nikes should give us the total number of pairs of shoes that she buys. So all we need to do is say C plus N equals 7 for 7 pairs. All right, now we have our two equations, and using them we can move on to the next step, which is graphing. So I will graph, and I will call each of these axes one of my variables. So I'm going to call, let's say, the vertical axis is going to be Nikes, and the horizontal axis is going to be Converses. All right, let's graph this first equation in red. And I'm not going to go through all of the steps of solving this, but because this is in standard form, you can use it to find both the X and Y-intercept and graph your line that way. So my N-intercept here, my vertical intercept, is going to be at 4.7 about. And my C-intercept is going to be at about 8.7. So I have my 2 points, which I can use to create my line. And my next step is to graph my second equation here, which I will graph in blue. And I can also find the N and C intercepts for this one, which are both going to be 7. So I'm going to, graph here and here. So they're both going to be 7. And my two lines intersect together, which is my fifth step, is to identify where they intersect so I can find my solution. And that solution happens to be at, this should be 5, 2. It'll probably look a little more accurate on your graphs, which have lines. All right, so what does this solution 5, 2 really mean? Well, if we have 5, 2 as an ordered pair, this means that the 5 came from my C-axis, or my converse axis. So that means that she bought 5 pairs of Converses. And the 2 came from the Nike axis, so that means that she bought 2 pairs of Nikes. If we want to check to make sure that this makes sense, we can take our ordered pair and plug it in to both of these equations, and it should satisfy both of them. And I'll leave that for you to do. Let's go on to the second example. All right, our second example has to do with a farm, and in the interest of space, I only printed half of the word problem. But the whole problem is that Griffin's uncle has a farm that seems to be overrun with dogs and chickens. Griffin is curious about just how many of each animal the farm has, and his uncle tells him that the dogs and chickens have a total of, and I'm going to mark this, have a total of 24 legs and 9 heads. Sounds kind of silly. How many dogs and how many chickens does Griffin's uncle have? Okay. First of all, what is this problem asking us? What are we trying to find? That's our first step. So we're trying to find how many dogs and how many chickens his uncle has on the farm. So by the end, I want to be able to find the number of dogs and the number of chickens. So keep that in mind. Second step is to define our variables. So we're going to have to know the number of dogs and the number of chickens. So those will be my variables. So I'll call dogs, I'll call D, and chickens, I'll call K. Okay, so now we have our variables, and now we have to make a system of linear equations. So let's start doing that. Why now do we need two equations using the information that we have? Well, we're told that the animals together have a total of 24 legs and 9 heads. Well, legs and heads are not the same thing, so I think we're going to need two different equations for each of those. So 24 legs. How can we distinguish between legs for dogs and chickens? Well, dogs have 4 legs, and chickens we usually think of as having 2. So I can say there are 4 legs per dog. So for every dog there will be 4 legs. So I'll say 4 times the number of dogs added together with 2 legs times the number of chickens should give me the total number of legs, which we know is 24. So that is my first equation. Second equation has to do with heads. Well, dogs and chickens both have 1 head, so we have 1 per dog and 1 per chicken. So I'll really have 1D plus 1K, but I'm just going to write D plus K equals, and how many heads do we have? Well, it says 9, so D plus K equals 9 is my second equation. All right, now using these equations, we can graph these lines. And like before, I'm not going to solve these right here, but knowing that they're in standard form, you can use these to identify the X and Y-intercepts. So our first equation here I'm going to do in blue on our graph. And when I calculate this out, I find that my D-intercept, and I'll just call this axis D and this one K for chickens. So my D-intercept is going to be 6. So I'll find that on my graph right here. And my K-intercept is going to be 12. So knowing that, I can connect those 2 lines and connect those 2 points and make a line. And now with my second equation, which I'm going to do in red, I can find that my D and K intercepts are both 9. So find 9 right here and 9 right there, and connect those 2 points, and I get a line, and I find that I have an intersection point right here, and that intersection point will tell me how many dogs and how many chickens I have on this farm. Well, that intersection point falls at 6, 3. So 6, 3 is my point of intersection. And what does that mean? Well, if I take the ordered pair 6, 3, I will find that 6 comes from the K-axis, so the number of chickens. So the number of chickens is going to be 6. And the 3 comes from the D-axis, or the number of dogs. So the number of dogs is 3. If I want to check that this is indeed my answer, I can plug this ordered pair into both of my equations, and I should find that it satisfies both. All right. Thanks for following along with me. Now you can try the problem at the bottom of your guided notes.